Welcome to this lesson on Object-Oriented Programming Revisited. Revisited because we already talked about some of these concepts in part 1, but we need to talk about things in a little bit more detail now. So we're going to revisit the discussion of primitive data types. This is going to be particularly important to you if we're going to be considering taking the certification exam. We also want to talk about classes again and just kind of summarize classes. We're going to talk a little bit more detail about classes because we want to talk about inheritance. So that will lead us to superclasses and subclasses. We also want to discuss interfaces, which we haven't talked about yet. And then we'll revisit the idea of a package and what a package really is. So the primitive data types in Java are the data types that are built into the language where support is provided for them. And those types, there are 8 of them total. If we're talking about the ones relating to whole numbers or integers, we have the byte, we have the short, we have the int, and we have the long. So there are 4 of these. They all represent integer numbers or just whole numbers, no fractional part, but they're different sizes. The byte handles 8 bits worth of data. The short is 16, the int is 32, and the long is 64. So it just depends upon the size of your number, which data type you might select if you're dealing with whole numbers. So all of these represent some sort of integer. Then, if we're dealing with real numbers, things that have decimal points, we would be talking about a float or a double. A float is 32 bits. A double is 64. That doesn't quite look like double there, does it? Here, let me fix that. Much better. All right, so those are the 2 data types that deal with real numbers. And then if we're dealing with characters such as A, B, C, or anything like that, there's a character variable, or character data type. And then finally we have a Boolean, which is representing the values of true or false. So those are the 8 built-in data types for Java. We also have things called classes, which is a big part of object-oriented programming of any language. And basically, when you're writing a program, you're trying to mimic something in the real world, whether it be a company or we kind of dealt with trying to mimic a vet's office, a veterinarian. But whatever your program's trying to do, you're doing something based upon a real-world situation. And so when you build a class, you're defining something that you're going to be implementing. For instance, if you have a company, you might have an employee class, and that defines all the information that you need for your employee. For us, we specified a dog class. So we created this general dog like this that represents the implementation of what is a dog. And when we talk about defining a dog, then we have to talk about 2 things. One is called state and one is called behavior. The state of a dog is the information about the dog. What's the dog's age? What's the dog's name? What's the dog's weight and height? And maybe what is its breed, since it's a dog. And those pieces of information, those are implemented in Java as fields, but they fields of a class, but they represent the different state of the dog, the different information defining what a dog is, what a particular dog will be. And then in addition to that, we have methods or functions, or it's actually in object-oriented terms called behavior, and it's what this class does. So in our case, it's a dog, so it barks, we might say wags tail, that type of thing, the things that the dog does. And in Java, these are functions, which we call methods, and we represent those as well. So every one of these is an actual function that we're going to write, a method associated with this class that defines the things a dog is able to do. Now these things in this particular case make up the dog class. So a class is a definition of what a dog is. It's not an actual dog, it's just a definition of a dog. And we also have something called an object or an instance. You'll hear both terms. You'll hear the expression that you're going to instantiate a class, or people will say they have an instance of a class, or people will say they have an object. And an object is an actual dog. So if we're talking about an instantiation of the dog class, we might be talking about something like this dog, this corgi here. That's an actual dog. Somebody's pet has a name, an age, a weight, and its breed is Corgi. So if we were talking about defining this, then we would do something like this, where we would say dog. We're instantiating a new variable of type dog, and let's say that the variable name is just my dog, and I'm going to actually create one of these. So I say new, and I'm creating a new dog. So now I can initialize all those fields of my dog. I can say what my dog's name is. My dog's name is Gladys, so my dog and the name field is equal to Gladys. And then I would go ahead and set whatever Gladys's age and her height and her weight and her breed, that she's a Corgi. And then if I want to use one of the methods associated with the dog class, and I want my dog to bark, then all I would do is say my dog, because that's my variable name, and the method that I want to use is the barks method. So if barks is going to expect some variables, they would go here. If not, that would be empty, and then that would call that particular behavior or method of the dog class. So those are classes when it comes to Java. Now we also need to talk about something called inheritance. Normally when you think of inheritance, you're probably thinking about inheriting something from your parents or your grandparents or that type of thing. The idea is very similar when it comes to Java. We want to go back up here to our dog class. And when we talk about inheritance, we're talking about inheritance among classes. But we need to talk about something called a superclass and a subclass. So to do that, I'm going to move over here into a clean area of my chalkboard here. And let's bring our dog class back up, just our general one. And what you may think of as being the natural idea of inheritance might be something like another class under here, which is a puppy class. And that might actually work. The thing you need to realize when we're talking about inheritance is the idea where you have a class that's a child class, and it can do everything that the parent class can do and more if we add more fields or more methods to the puppy class. So that could actually work, especially if you think about if we're mimicking a vet's office, then a puppy class might need to have shot records. Or there might be, some things that you would deal with at a vet's office that you would have to deal with a puppy that you wouldn't have to deal with a dog. So that idea might actually work. But there's another way to do that, and that is if you're a vet's office, you probably see all kinds of pets. So you might have this pets class up here. And actually the pets class might have things like name and age and height and weight, because whether it's a dog or whether it's a cat, or whether it's a horse, or whether it's whatever, it's going to have a name and an age and a height and a weight. So all those fields could be part of the pets class. And then the dog could be a child class of pets, and so could a cat, and so could a horse, because they have some sort of shared information and even some sort of shared behavior. But the methods that are particular to this object would, like a dog, would only belong to the dog class. For instance, the dog is going to have the barks method, and so could a puppy. A cat is going to have a meows method, and then a horse is going to have the neighs method, neigh. So these are going to be methods in these particular classes. So the way that this works, the nomenclature that we use, a lot of people will talk about parent class and subclass. So in our situation, the pets is the parent class. Dog and cat and horse are all children or child classes or subclasses. And then puppy is a subclass of dog. We also will use the term in Java where this is a superclass. And then the children classes, those would be subclasses. And then so puppy is a subclass of dog, which is a subclass of pets. And dog is a superclass in relationship to puppy. So whoever your parent is your superclass. Whoever your child is your subclass. Now the rule is that in Java, a class can only have one parent. There are other languages that are object-oriented that allow you to have multiple classes as your parent class. That is not the case in Java. Now, you can have lots of subclasses. If you have lots of things that are related, we don't really have anything that would fall into place in this particular example, but a very common example is a situation where your parent class or your superclass might be a bike, and you have lots of different types of bikes. There's mountain bikes and road bikes and racing bikes. So you might have lots of bikes under here. You might have the mountain bike and the racing bike and so on. So you might have lots of subclasses, but the mountain bike can only have one parent. The racing bike can only have one parent, and so on through the list. So they can have their own children and go on down, but there's only one way back up to your parent in the particular inheritance tree. All right, so that should give you a little bit of an idea about inheritance, and we're going to talk about it in more detail and implement our own classes and subclasses very soon here. Now, there are two more concepts that we want to talk about when it comes to object-oriented programming. One is called an interface, and the other is called a package. Now, we mentioned packages before. Packages are just the collections of all the classes and all the files and all the information it takes to make some entity. So if you were creating this veterinarian shop that we were talking about, or clinic, then you might have a package that is vet clinic, and it would have all the information about all the different types of animals and their methods, and then maybe the billing class and all that type of thing, and you would package that all up and then be able to access it. And we'll be talking about those in more detail. So far, we've been using existing Java packages like the java.lang. When we see java.lang, that's an actual package. It has the support for like strings and all those things in it. So we're going to start just by continuing to use some of the Java packages, like the math functions are in java.lang. So we'll be talking about those. But let's back up here and talk about this thing called an interface. Right now, what we have done so far is we have created classes and their methods and their fields and used them and implemented them, and in part one did lots of programs with them. What an interface does, it doesn't actually implement methods and implement fields, it just defines them. It's a definition. And the idea is that if you have a formal software project going on and you have several people that are contributing to this, you define your interface. You set the rules about, okay, this is this particular class and it has these fields and it has these methods. And then each individual person can go in and write the methods. You don't care how they write the method, but part of the definition is what it looks like. What does it return? What does it expect? So they can go out and write whatever methods they have. Maybe they have a method that returns an integer and it expects 3 values, something like that. So you make those definitions in this interface. So it's not concerned with actual code of implementing the methods and the fields. It's just defining what they are, and then you can go in and implement those yourself. So we'll be talking about those in more detail in a later section as well. But hopefully that gives you a feel for what is really the core pillars of object-oriented programming with our primitive data types. And then we talked about classes and objects. That led us into inheritance, and we just briefly touched on interfaces and packages, but we'll be talking about them in this particular course in more detail. Thank you for joining me for this first module where we do a quick review of object-oriented programming and talked about a couple new concepts. I hope you'll continue on with me as we delve even deeper into Java.